Hi, my name is Yuzan Edward. My metrics number is 221061395. In this case study, I will present the introduction. In the modern era where communities are assisted by modern technologies and gadgets, there is still a problem of miscommunication. This is due to a misunderstanding of the receiver or the sender has difficulty in conveying the message. In this topic, alphabet recognition, we emphasizes the difficulty of conveying a handwritten message in tourism. In this modern era, every person that is old enough of age has smartphone in order to assist them in their daily life. Smartphones nowadays are even equipped with a translating feature that helps tourists to guide themselves through and unfamiliar places. Especially when they are traveling to a country that are not fluent in English or did not emphasize English in their education system, travelers often have trouble communicating with the locals. A translator application that are easily downloaded in smartphone can help a tourist to communicate with the locals. However, most translator applications have trouble deciphering a handwritten message. Some of the local stores, even in the city, will provide a handwritten message, such as the food menu or even the lavatories. Therefore, a machine vision system that can read and decipher a handwriting are studied in this case study to create a better translating application that will be able to help tourism become easier. This case study emphasizes in assisting a non-English speaker and reader to be able to guide themselves through places that uses English alphabet. In the ever-evolving landscape of machine vision, our comprehensive case study embarks on a journey through the nuances intricacies of recognizing handwritten alphabet character, with a keen focus of the character A, B, C, D, and E. The overarching objective is to meticulously engineer a sophisticated system endowed with the capability to discern this character with a precision born out of judiciously curated set of training and testing images. In navigating the complexities of this pursuit, our chosen ally is MATLAB software, a preeminent platform celebrated for its commanding presence in the domain of image processing and computer vision applications.
My name is Mingwei Yang. My metric number is 221061413. And now I'm going to talk about the objective of our case study. To design a system for recognizing handwritten alphabet characters, we need to create a dataset featuring 10 intercity clustered training images and 3 meticulously chosen testing images for each of the characters. The characters we choose are A, B, C, D, and E. We utilize diverse image processing techniques to elevate the accuracy of character recognition. The motivation behind is from the growing need for efficient and accuracy character recognition systems, particularly in applications like optical character recognition, automation, automated document processing, and human-machine interaction. Handwriting recognition plays a crucial role in bridging the gap between physical and digital worlds, making it a pertinent area of study. The background of the research is from image processing, pattern recognition, and machine learning. Handwritten recognition poses a challenge due to variations in individual writing styles and other environment factors also. To addressing these challenges requires a comprehensive approach to integrating various image processing techniques for optimal results. And last, the software we use is MATLAB. Why we use MATLAB? MATLAB is chosen as a primary software for its extensive capabilities in image processing, numerical analysis, and algorithm development. It is user-friendly interface and rich set of libraries make it an ideal tool for implementing and experimenting with complex image processing tasks.
Greetings, my name is Elwin Chinweijie and my metric number is 221061394. So right now, I explain about the methodology we use in this case study. There's some steps involve the following key components. The first one is image acquisition and sampling. Second one is image processing, and the third one is feature extraction and classifications. I will talk about this in more detailed way. So here's our flow chart. So basically, we start with image acquisition, which is the original RGB image, and then we do some grayscale image conversion. Then we proceed to adaptive image processing techniques such as adaptive histogram equalization, Gaussian smoothing, Sobel edge detection, canny edge detection, and we combine both Sobel and canny edge detection techniques. I'll explain it in more detailed way later. Next, we save the binary image, and then we extract the features such as parameter, GLCM features, texture features, shape, and so on. After that, we store all the feature data and class label in the cell array for training. So there are 10 images we use for training, and then 3 images we use for testing. Next, we display the original image and its binary version in the subplot, and then we adjust the spacing between subplots so that we can see the difference between each images in clearer way. Next, we convert the cell array to a table for training data, and then we display the training table. So we'll see all the feature data and their value in MATLAB software. After that, we save the training table into a CSV file for further processing use. Next, we repeat the whole process for the testing images. Next, after that, we do a program that can read the feature data from both training and testing data table, and then we use the KNN classifier for letter classifications. After that, we calculate the accuracy, and then we display the output result as well as the confusion matrix. Next, we made some adjustment to further improve our accuracy, and then we finalize the program and write a report. All right. So right now, I'll proceed to the procedure we use in this case study. The first one is image acquisition and sampling. So basically, we obtain a data set of handwritten alphabet characters such as A, B, C, D, E, and so on. So alphabet consists of letter A to letter Z, which is 26 letters. So it will be too many and too overwhelming for us if we do all the letters, the whole set of letters alphabet. So we plan to do just for 5 letters, which is A, B, C, D, and E. So we obtain the handwritten alphabet characters A, B, C, D, E with 10 training images and 3 testing images for each character. So all the training images are handwritten by different people. And then we ensure there's a variability in writing styles and environmental conditions to enhance the model's robustness. Next, we use a high resolution camera, which is our smartphone camera. We set it into 1920 times 1080 pixels to capture the images. So all the images are in high resolutions, full HD. Next, we save all the 10 images and 3 images into training and testing folder separately in PNG format. After that, we proceed to image processing. So first of all, we convert all the RGB images from training folder into grayscale for simplifying the subsequent processing step. Next, we apply some Gaussian smoothing for noise reduction. We also enhance the image quality using adaptive histogram equalization. Next, we utilize Sobel and Kenny methods for image thresholding. So basically, Sobel and Kenny are edge detection techniques, and then they have their own effects. So we notice that if we combine both Sobel and Kenny techniques, we get a better edge detections. So we got a clearer alphabet with sharper edge. Next, we also create a subplot to display all the images. Then we look through each image type, which is image A, images for A, B, C, D, and E. Next, we repeat the whole same process for the images in testing folder. After that, we move on to feature extraction and classifications. We extract some of the relevant features such as parameter, texture, eccentricity, shape, and so on from the preprocessed image. And then we implement a classification algorithm to distinguish characters A, B, C, D, and E. We use the KNN classifier because it is simple to use and it is able to handle multiple class label, multiple data with class label. Next, we evaluate the model performance with KNN classifier as well as confusion metrics to calculate the accuracy using the testing data set. So right now I'll do the demonstration for the in MATLAB software. So right now I'll display the training images. So I choose image A1 for example. So as you can see, so this is our original image A1. So we can see that the background is slightly yellow in color. And then this is our handwritten character A. And then we convert it into grayscale image. As you can see, the background become white. And then we enhance the image using contrast enhancement and sharpening. And then we smooth the image using Gaussian smoothing to reduce the noise. Next, we use Sobel edge detection to detect the edge of the character. And then we also use Kenny edges to detect the edge. As you can see, some of the lines are not connected to each other, but in Kenny edges, the lines are perfectly connected, but there's unwanted lines appear in the background. So after that, we combine both Sobel edge detection technique and the Kenny, and then we we reduce the threshold value so that the unwanted lines can be eliminated. So here's the combined techniques, and then it produces a perfect letter A. So as you can see, the lines are quite sharp and complete. So right now I'll try to run through the trading program. So as you can see, there's in the output section, there's a 50 data set, 10 for each character, and then each of them have different values. So there's a value for eccentricity, parameter, contrast, correlation, energy, and we classify it based on different class. So there are 5 classes. Class 1 is letter A, class 2 is B, and so on and so on. Next, moving on to the testing program, it's basically the same as the training data. It uses the same method. The only difference is testing data only consists of 15 images. So right now, I will demonstrate the KNN classifier for this program. So as you can see, the accuracy calculated for this program is about 53.33%. So if we look at the confusion matrix, we can see that 3 images with letter A is classified correctly. One images with letter B is classified correctly, and the same goes for two letter C images, and one letter D image, and one letter E image. So some of the images are not classified correctly due to the some of the limitations.
My name is Sid Sun Wei. My number metric is 221061454. Okay, so I will explain about our case study discussion and conclusion. So I will explain roughly about our discussion is the case studies outlines the development of a handwritten alphabet recognition program using MATLAB. The process involved image acquisition, preprocessing through various techniques like RGB to grayscale conversion, adaptive histogram equalization, Gaussian smoothing, and edge detection. Features such as perimeter, texture, contrast, and eccentricity are extracted and stored in a table for both training and testing images. The classification is performed using the k-nearest neighbor (KNN) classifier. So initially, the choice of total area as features and certain morphological operation result in full classification accuracy. Adjustments are made by changing parameters, lowering the threshold, and combining edge detection methods, which significantly improve accuracy from 13.67% to 53.33%. However, it is acknowledged that the accuracy is still not satisfactory, and the study suggests the implementation of deep learning techniques like optical character recognition, OCR, short form, for better performance. Okay, so we proceed to the conclusion. Okay, so here's our conclusion. Okay. The conclusion emphasized the importance of addressing miscommunication in handwritten messages, particularly for tourists in non-English speaking region. The machine vision system developed using MATLAB aims to enhance translation capabilities by recognizing English alphabet's character. The challenges of handwriting recognition, including style variation, are addressed through a comprehensive approach involving image processing, pattern recognition, and machine learning. MATLAB is highlighted for its suitability in implementing these complexities, and the system is seen as potential solution for improving accessibility and inclusivity in travel experience. Thank you.